Hello everyone. Sit back and prepare to enjoy this talk from Devfest Montreal.
Is everything good? Ready for starting? Right. Okay, let's start with the next talk. So the talk is called Smart Persona. It's an accelerated consumer insight. It's more like a tool for consumer behavior. Okay. So my name is Angie Ariza. I'm the AI principal developer in Plus Company. Plus Company is an umbrella on different agencies of marketing and media. So there are other companies like Cosette that is mostly known on Quebec, K72, and some other more interesting ones. In our team, we are doing, we're mostly AI developers, software developers, and we're trying to create different kind of products. So a Smart Persona is the biggest product that we have. It's divided in different small sub-products. Let's think how, for example, one of our clients wants to talk with their perfect consumer, all the questions that they can ask to the perfect consumer. But instead of going and ask to a real persona in real world or showing maybe some new product that is not outside in the world, they can ask to the synthetic personas. So these synthetic personas reflect the real consumer from the real world, but they are a little bit more safe. They have no family. They're not going to share any information, so everything is inside. And our clients can have directly the insights that they want from these personas. That is like the basic idea. Okay. So what I'm going to show is the next video. I hope the audio function.
Are you ready for AI's marketing revolution? For Mongo, it starts with synthetic.
I think it doesn't sound.
Synthetic data.
No. Is there a way to share it?
Are you ready for AI's marketing revolution? For Mongo, it starts with synthetic. Are you ready for AI's marketing revolution? For Mongo, it starts with synthetic data.
Oh, it's not working. Let me just see. ¿En video pasaje? Ah. Thanks.
Are you ready for AI's marketing revolution? For Mongo, it starts with synthetic data, which integrates over 40 data sources like Statistics Canada and Numeris RTS, with our clients' first and secondary data to deliver fast, accurate, and privacy-compliant insights. Gartner predicts 60% of AI data will be synthetic by 2026. We connect this synthetic data with large language models in our new Smart Persona tool, allowing you to create custom virtual personas you can.
I'm not sure. Is you can listen? No? It's a bit. Okay, let's finish the video and I will explain it a little bit after.
Have realistic conversations with. Like Mike, a married. Ready for AI's marketing revolution? For Mongo, it starts with synthetic data. Integrates over 40 data sources like Statistics Canada and Numeris RTS, with secondary data to deliver fast, accurate, and privacy-compliant insights. Gartner predicts 60% of AI data will be synthetic by 2026. In our new Smart Persona tool, allowing you to create custom virtual personas you can have realistic conversations with. future handyman. Interact with Mike to understand his needs, preferences, and challenges. These personas reflect authentic consumer behavior to help you make smarter, data-driven decisions. Use them to test ideas and run focus groups quickly and accurately. With Smart Persona, marketers can optimize campaigns, refine strategies, and stay ahead. It's the future of marketing. At Monvo, we're ready for the new era of AI.
Thanks. Okay. Basic. Okay. Maybe if you can read on the subtitles. The basic idea is presenting like we have a lot of data to create a synthetic population, but with different other insights and the design from our client, we create a specific persona. So it's a persona, it's not the LLM that is behind, it has their specific inputs like a name and a specific race and a specific gender that reflects what the client needs. Okay, so the client can ask what they need for that persona and have the insight or the answer right away. Okay, that's the basic idea. So let's think it's not just one persona one-on-one, it could be a focus group, it could be like many insights at the same time. Okay, so that is like the basic idea of a smart persona. Okay, here is some data on this. So basically, it's a consumer research tool. It helps creating the synthetic personas, create our clients to go easily and fast through the behaviors, their thoughts, what will be the thoughts, the interests of the personas, what will happen on different scenarios. What if I change this in this product? What is more important, for example, for you being, for example, a mom with 2 kids that works from home? What is exactly what is in your needs to buying or not buying this kind of product? It goes like that. So basically, on the performances that we have is doing the consumer research in real world is very expensive. Like you have to hire some people, hire the researchers, thinking on all the specific questions, and maybe by the time when you get the insights, it's too old. It's been 3 months since the time that you start the research and you get the insights. You're losing time. So we're accelerating those kind of insights that you can have it right away and you can work with them even before launching the product. That's the basic idea. So some of the key metrics that we have is 60% faster on getting the insights from the audience, from the profiling, the specific profiles that they may want to have. And what we have seen is our personas are answering is more than 96%, but I'm being pessimistic. 95% of the time, their answers are the same, like real humans in the real world. So it's really accurate. And it's very interesting also. All of this is based on all the different databases that we have. It's not only, again, just the LLM. So what I think is the core value, what I want to show you, is like we can simulate these groups with these personas, these audiences, virtually, having the response right away. And we can validate hypotheses even before investing everything in the marketing. Before it goes outside, we can test it inside. And we can create like new audiences that maybe don't exist, but we think it could be there. It could be like a new interesting consumer. Okay, so that is the main core value. So what I wanted to show you today is one of the tools or the methodologies that we have found that are very powerful is RAG, Retrieval Augmented Generation. So I want to go through what is RAG, the different architectures, and I'm going to go a little bit more incrementing the difficulty for saying it, the depth, and I will show you one persona that I created for this talk. And you can ask questions, or I have some questions to ask. So basically, let's start for RAG, the foundational pipeline. Something interesting that I found is like the first time that we had something regarding RAG, it was in 2017, and it was called something like reading Wikipedia to answer open domain questions. So they were using reading documents to drag that information into Wikipedia. That was like the first use case. That was 2017. And then we have in 2020, the first time that someone uses RAG as the word that we know today, Retrieval Augmented Generation, for knowledge-intensive NLP tasks. This is 2020, so it was before the LLMs boom, so it exists. But LLMs definitely increment the power of RAG, and it's something that I want to show you. So I think this is like a better description today. So at the left side, we might have like a little description. RAG is a technique that enhances model generation by retrieving relevant information from external sources. And the external sources could be database, chat sessions, internet, could be images, could be multimodal information, and so on. And at the right side, we have like a very simple architecture of a RAG. So we have a person, we have a prompt, the prompt retrieves information with context to the query, and it goes to a model, and we get the response. Okay? The model, the generative model is like the brain, but the RAG is like the library cards, the mnemotechnia, like when do we want to tailor the search, okay? And this is even better. Like I think RAG combines parametric knowledge, pre-training language models, with not parametric, maybe external memory, and overcome some of the limitations. For example, when it comes to accuracy, specificity, maybe also reduce the hallucinations because they are telling it where to go through, and we have grand truth. We have the basis to go to compare the information with. Okay, so if you remember, this small architecture of the RAG is very simple, but RAG looks more like this on the moving parts. So we have different parts on the RAG. This is like the basis, like what it usually has. So we have certain private knowledge in this case. It could be text, it could be images, it could be the internet. Usually when it's text or information that we really know and we want to have, we create embeddings for that information. The embeddings go to a database. Maybe the database will have some models, like some clustering or something that we want to do a better vector search. In the other side, we have the interface. It could be a chatbot, but it's not the only way. It could be an app, it could be an assistant, it could be an agent, it could be anything that is going to RAG the information. And we have the prompt. The prompt is like the prompt that the RAG has itself, and the prompt that receives the query, understands it, make the call to the vector database, and then the LLM that receives everything. We also have another layer. Usually, this is part of the hardest part of RAG. We have to take care of the observability, evaluation, monitoring, security, and some guardrails inside the same RAG. Okay, so there are many moving parts. Not all of them looks like this, and usually they are even more complex than that. So some of the challenges is we have the retriever challenges. So embedding the models, which model are we going to use to embed it? What will be the dimensions? Why are we using that one? Is better for certain contexts or for other? What will be the database? Different databases, in which cases will be the best for us? Even not only vector databases, it could be graph databases. How are we going to go to do the vector search? Are we going to do certain indexes? Again, are we using another model to improve the vector search? It's just like a linear cosine distance or something similar. What are the heuristics? It's like, are we basing on business information? Are we using some more classical AI modeling? What will be the basis, like the grand truth to compare the retrieval information? And on the Gen AI, of course, we still have like what is the model selection? What will be the best model for which use cases, depending on the data types? All the prompt engineering challenges. Are we using maybe chain for how we call it? Oh my God, change of thought or any of the other techniques to try to make it think on the RAG, and also on the operations. When these go to production, how are we going to take care of everything? At what time we notice if this is getting good results all the time, not good results, is being safe, maybe it's being populated with bad information directly in the interface. So RAG is not just adding a vector database and getting the vectors from it. It's more complex than that. But it's also more powerful. So here are some architectures on RAG. So this is the very simple architecture. So we have a user. The user submits a query. The query goes to goes to the comparison on the vector. The query is embedded, so that way we can compare it with the vectors in our database. Then we retrieve what are the more closest to the query or the more related according to the context. We combine the query with the context. This goes to an LLM, and we generate a response. So this is like the basic idea, okay? But then, for example, we can start adding some more complexity. What if we add memory into the RAG? So if you notice, this part is the same as before, except because we have in the conversation history, we're storing some memory. So this means like if the user is going to ask like a very similar question, and in the memory we know that the question is very similar, we already have some more context for maintain consistency, maybe for creating more relations in the context. So basically this incorporates, the memory incorporates the ability to be more aware on past exchange, or maybe on populating and enriching the context, and also keeping the consistency, which is very useful. Then we have, for example, the multimodal RAGs. So what if the user is not only communicated with text, but also is using images, is using audio? So let's say, what type of input is the input? We might need to have different embeddings depending on the type of data. And again, are these embeddings something that we can communicate in a unified vector database? How are we going to communicate? Those are part of the challenges. Let's say we retrieve the media or the data that is in all the multimodal forms, either text, images, audio. All the multimodal information goes to the end node, and we generate a response. So this is incrementing the challenges. And if you notice here, we don't have memory, we don't have anything. It's the simple one, just adding different dimensions on the type of data. Okay. So Agentic RAG, this is the one that I'm going to show you today. So the last 2 years, we've been talking a lot about agents, but now it happens that we can have agents also in RAGs. So that's the importance on being able to manipulate or to understand infrastructures, is what I think. Once you understand what is the simple, how it works, what are the challenges, you can start adding more complexity into it. So let's think that right now, each part or different parts of the moving parts of the RAG could be an agent that is autonomous, that can take decisions on the different steps. So here is an example. We have a query. We have an agent that orchestrates. So it can, for example, analyze what is the type of data, in which context is better, and can reroute that depending on, for example, we might need another planning agent to take care of that, or is something that goes directly into web search, or goes to the memory, or is exactly part of the information that we already have in the database, so they can take decisions on what is the best way to route that information. And after that, we have all the parts, all the responses. For example, it could be all at the same time also. They could be parallelized. So we have the vector information, the multi-step retrieval, maybe if there were some plans. For example, we have all the information, but could happen that the information needs to be in a hierarchical order to make sense, or maybe it's for a time lapse. It needs to have like time. Needs to be time aware. So the planning agent could help with that. Also, if there is any research, and here, is that research makes sense with what we need? Is adding more context, or is just creating more confusion? Do we take it into account or not? So the agents can take care on that part. And to show you, this is an advanced Agentic RAG. So this infrastructure is exactly the one the example that I brought today. So let's say we have different steps, and I want to show you here a little bit more in detail. So we have an intelligent orchestrator that is like the brain of the system. It's like the one that takes care, like, let's classify the intention. What is the intention of this query? Okay, so it's not only the exact words, but it could be based on if they have memory, if they have general knowledge, it could be based on the instructions that it has. Then it can parallelize all the searches. So let's say I don't have enough information here of what is the context, so I'm going to do a research on all the resources that I have, the memory, the vector RAG, the web search. And after that, we can have certain quality control. It's like, okay, we found something on the internet. Does this make sense? The quality control, I think, I didn't put it here, but I'm going to show you in the next slide. So we can have certain validity control, validate the responses, and reroute it if it's necessary. So we can have certain loops that are intelligent in between them. Then we have the vector RAG, is the one that aggregates all the information. This information makes sense or not, or doesn't make sense. So it can be autonomous on that. The same happens with the memory, for example. If memory is an agent, it will understand when to add, for example, new memories or just keep the ones or not repeated information. So it's very useful to having them there. And at the end, even the one that generates the response could be intelligent. In this case, for example, even if it's Gemini, but we can have a specific agent there that not only use all the information randomly, but does it with a specific intention. Okay. So with all this infrastructure, if you notice, it's becoming every time more and more complex. It's complex, but it also has certain advantages. So it's flexible. You can change, for example, just one part of the nodes. At certain point, you can connect an NCP if you want the RAG to be connected to an agent that does something, for example. So it allows you to do all of that and to scale easily. So easily in the sense that I'm not touching, for example, the database. Even if the database is huge, I'm not going to touch that part if needed. I can populate it just in another part of the infrastructure. Okay, so let's do something. The app that I'm going to show you has this infrastructure, but I'm going to break it in small pieces. So this is how it looks like. So we're going to have like a fast API that has an orchestrator that routes the queries, combines the information, and then we have like a conversation with that. So we have certain, a first node that calls Gemini and calls a database that has a vector storage, the chat history, and some more user context. I'm going to talk to you about this later. We have certain memory agent, and we have the Tabili search agent. So the one that is intelligent enough to go on search and look for information, news, maybe what is the weather, what is happening today, and retrieve that information. So it looks a little bit like this. On the external services, we have Gemini, the one that we know, with their invariants. So the database looks a little bit like this. Let me show you. So basically, this is the database. And let me see a moment. So it looks something like this. I'm adding text. So this text is certain knowledge that this RAG should have, or this chatbot should have. So Blade is the most noble cat. I usually dress in black. My husband, as Camilo, is the most amazing. My first time, this is my first time seeing the snow in Canada. And here in each of these, we have the invariants, okay? So basically, the RAG what looks is for the embedding, and then it brings the text that aligns with the embedding. Okay. So this is the first database that we have in the back. We have a vector database. Then we have Tabili, the one that do the searches. So anytime that we ask something, it retrieves updated information, like what is in the news, what is the weather like today, what is happening in Montreal today. It will bring the information. And then I added another layer that is a photo storage. So I added photos of Blade, clothing photos. Like, let's think about this. I want to ask, for example, I don't want to think every day how to dress, because I'm not from Canada. The next winter is going to be my third winter. I still don't know how to dress, and here the heating is everywhere. So usually I think a lot on how to dress. I don't want to be cold, but I don't want to be hot all the time. So instead of doing that, I can add pictures of all my clothing to this agent, and it will answer the way I answer. So it will tell me, instead of me thinking about it, it will tell me what to dress. And Blade, for example, is this little cat. So I want you to see the pictures for a reason. And the reason is like, when I pass the images to the LLM and create the invariants, I can tell, okay, Blade is a cat, he is black, this is his name, and he has a Tesla. But what kind of Tesla? This Tesla is a toy, right? It's not the big Tesla to drive through the city. But I'm not specifying those kind of information. That is what I want you to see. Also, some other things from Blade. So I'm giving the less context possible, but I want the LLM to be able to create the right invariants, because that's what I created it for, and do that I do all of that work for me. And here is other picture of Blade. So basically, this is what is going to happen. We ask a question, the orchestrator redirects the question, gets the context. Is the context from one of these agents, the vector, the tabili, or the memory? So it goes to the database. If it's from the knowledge database, returns the information. Let's go back here. I got the information from the database. Then it generates another call with more context to Gemini to send information, get a response, and at the end we have the final answer. Sorry, here. So let me show you. It will look something like this. So it's giving me some information like, hey there, I'm Angie. The AI principal developer with over 5 years of experience, quite a journey. I'm a data scientist. My AI path is meaningful. I grew up in Colombia. And here I can see the sources, the internal sources. So it goes to memory because I've been testing this since yesterday. So it already has memory. It goes to my family pictures and some other references, maybe because it created it. So it didn't went to Tabili. So the call is not necessary to go on internet and look for another Angie. It's specifically just looking for the knowledge that they have from Angie. So let's say it's like, how is Blade today? So Blade is doing great. He's probably found a prime napping spot, maybe. So is Blade that sad Blade cat and not the vampire hunter or any other? And even though he perhaps is recalling the movies from Marvel from the 80s. And again, in this case, it was added more text. So in the knowledge, I only add photos of Blade, and I tell Blade is my black cat and everything, but I don't tell anything about any movies or more information. So here I can see he goes to the pet vectors, family vectors, memory, and also on Tabili. It did some research. So it's adding every part of the context in the same response. Okay. So let's see. Okay, let's see. That's an interesting question. As an AI, I don't actually have a physical body. In this case, if you notice, we're seeing the brain itself, a body, so I won't be attending to the Devfest in person. I think I didn't add that information. So it's just, in this case, is Gemini completing the information, and then it's adding some real information from me. It's like the type of clothes that I use is black, most of the time white, purple, or burgundy, but nothing like yellow or other bright colors. Okay. So let me break down a little bit better on that to show you. So this is what is happening in the backend. So we have the orchestrator, is the one that receives and coordinates everything. It routes the questions, decides which source to query, the vector database, the Tabili, and there is a condition whether to go to Tabili or not. It's parallelizing, so there is an agent that runs everything at the same time. That's why it takes time also. There is a change of prompt, so it's sequential. It has certain steps on when to go exactly to see in each agent. It evaluates, so for example, it's checking for the photos. The photos are not in the same database, so it's checking in another place, and it's saving memory, okay? So it looks something like this. Let me see if it's more clear. Oh my God. It's doing this. So in behind, we're having several patterns. The patterns is the orchestrator receives everything from the user, Then it tries to router is like always go to the vectors at the vector database, not all the time to Tabili, just under certain conditions. In this case, vector or Tabili. So with the vector, it goes to the embeddings, search for the information, get the information, and here there is an evaluator. It's trying to think, is the photo from, for example, the question is from Blade. Is the photo from Blade? Is the photo from Angie, from the family? Do we need to add images or not? And it goes to the response if needed, and it's saving everything, in the memory. So that way it's also learning. Every time that we have an interaction, it's becoming more custom with me, the kind of questions that I ask. Okay, so that feedback comes back to the vector, Tabili, and the memory. That is what is happening in the backend. Okay, and here is a better example, a better use case. So let's say, what are you doing during this weekend? This is the type of response. It's like, well, Saturday I probably sleep until 9 a.m. is what I usually do. Tomorrow I will definitely make some arepas, is what we also eat during the weekends. The weather looks nice in weekend in Montreal, around 15. I think this was some other day. But maybe we're going to Hudson, it's a place that we like to go. So in the backend, this is what it's doing. It goes to the three agents, the memory, the vector, Tabili, looks if there isn't anything there regarding the same context in the databases. If there is certain information there, it will save it, goes to Gemini, try to have everything together to look natural and conversational, and goes to try to evaluate the response. If the response makes sense, it will save it in the memory and answer. Okay. This is with this type of question. But let's think about this one. Some of the other questions that I ask is, what is your favorite restaurant in Tokyo? So I've never been in Tokyo, but there is certain information there that they use. So in the retrieval information, there isn't anything about Tokyo, but there is something like about loves sushi and loves traveling or going to places like Salem. So I haven't been in Tokyo or to Tokyo. I would love to go someday. My travels have been most around Canada and the US. For food, I am a huge fan of sushi. So what is happening here is like there is anything there, but even if it's not there, it's not inventing. This is one of the strongest abilities of RAG. So it will try to all the time go to what is in the database, what is the ground truth from them. If nothing is there, it will answer like, no, it's not there, but I'm going to use some of the other information that is indeed there, which is really, really useful when we want to again, control the hallucinations. It's not the only technique, but it helps a lot. Then we have, what it found is sushi and Salem. So it's using that as part of the context. And it's honestly saying that I don't know. So it's not trying to answer all the time with the information that it can have in Gemini. Okay, and it returns a conversational answer. Okay. Then we have what happens when we have different, more complex questions. This is the power of the memory. So the first question is like, how do you get into AI? So I started with my physics degree in Colombia, then I start working. Second question, what is the hardest problem that you have solved? To giving you more context to you, is like I've never put any information exactly about this in the database. So it's trying to infer from the vector database and like the prompts that had in each agent, what will be the best answer, and the answers are very accurate. So that is what is doing in this case. And it's not also doing that, but it's using what it has in the memory. So it remembers all the conversations. It is saving what is important from each conversation, certain context, and is reusing it in the next conversation. Okay? So it's not repeating, it's just like, let's continue with this part. It already knows this. It already knows this, so it's like, okay, there's been so many, I work on clustering, classification, Third question, are you working on anything exciting now? So actually, yes, I'm working on agentic RAG system. So it's continuing, it's stepping on the previous information to create new answers with better context. So there is a memory loop in there. If you notice, each of these codes are communicating themselves through the memory. Okay. So the vector RAG retrieve career profession plus technical experience, and is so it's self-awareness or is meta-awareness. It is awareness of all the metadata that it may have, is what it's trying to say. I will referential them even if it's not in the database, but it's in the memory, which is really interesting. And also it's keeping the personality. The personality is something that I put since the beginning, so it's keeping it in all the interactions. Then we have, for example, it's also time aware. That's the reason why we use, for example, an external internet search tool like Tabili. Let's say the LLMs usually are not updated till today, but I want to know, for example, what is the weather of today. I wanted to understand whether it is in the morning or is at night. So that's why we're adding that part of the context. So in this case, it's like just, hey, good morning. The bot is saying morning. Thought honestly, mornings are rough for me. I'm such a night owl. I probably work about this and that and take a coffee and go to French classes. So it's using the user context. It's not only the context that is creating in the calls, but also the context that I, as a user, are giving it. So within the time, all the interactions with the different users are going to be custom, which is also interesting. So next time that I'm asking, if I mention something that is not in the rack or the databases, it can bring back that information. Okay, so here are some of the advantages, but let me show you, I didn't show you the code, and this is a Devfest, just 1 second. So I want you to see how it looks in the code, but I will make it simple. So usually it's just 2 parts. In this case, it has a front end because it's what I created for showing you. And in the front end, there are certain pictures, like the images from Blade and else. But in the backend is the interesting part. So we can have just the agents in one side. We have the memory agent, the orchestrator, the Tabili agent, and the vector RAG agent. We have here how to call or to add new information to the databases. We have the LLM, how to call Gemini if it's the case, or any other LLM. Certain configuration, more configuration. And yeah, this is how each of them looks like. The orchestrator is the important one. Is the one that tell where to go. They can go in the parallel on all the nodes at the same time. Or, for example, we can have graph racks. So we can have different nodes, and the nodes can communicate in both directions. This is the one that tells how to do that and where to do it. Okay, certain code information and else. And let me show you. Here is the questions that I was asking. What is your favorite restaurant in Tokyo? That's a great question. I don't have any personal favorite restaurant in Tokyo since I haven't had the chance to visit. A dream of mine is to explore the city. However, I absolutely love sushi and else. Okay. Does anyone would like to ask a question in the public? More questions about Blade? Okay. What are Blade's costumes? That's a funny question. You know, I don't have any costumes for Blade. He's a pretty noble cat. Maybe he's not reading correctly the images. Was an error that I was having. He's usually busy. Is he playing with his Tesla? Oh, haha, that's a good memory from our cat. They definitely works with his Tesla. He's got his own little routine, you know. It's more like a playful interaction than actual driving. But he takes it very seriously. He also loves playing with his fish and rat toys. He's such a noble cat, which indeed he has these toys. Always keeping me entertaining, especially when he decides to lap on my chair and on the perfect spot on my nap. He's truly a special part of my family, and again, is only looking for the vector information. Okay. So what are some of the advantages? I have already been telling you some, but I want to show you in this case. Let's say as I show you in this small part, just putting the sources here gives me an idea on where the RAG is getting the information from. At big scale, or whenever that is deployed, is very useful for tracking the workflow, so we can know exactly what is failing. It's in a specific node, it's for a specific reason, and if everything is separated, we can IO the errors, which is very useful, and it's fast. It's very fast. It could be also more dynamically, as I told you. For example, we can connect a server, an MCP server, and it's very easily. Like it's just another node, and we can connect like what under which conditions it can go there. And because this is an agent, it will understand better when to do it. It could be more optimal. So, for example, adding an MCP, we can add parallelization, we can add graphs, we can add change of thoughts or different other techniques. Okay, and this is what I found useful, scalability. For example, multilingual support. In Montreal, everything is bilingual, at least bilingual. But what we try to do is that it can work in any language. So even if we ask, I don't know, in Chinese or in Spanish, it should be able to understand, to answer. So we don't have to change anything in the backend. We don't have to change the database. We don't have to change any of that. Just having one agent that is aware of the language can make that happen very easily and very fast. So we can easily have like multi-language supports in different products. Also multimodal data. So for example, if our clients wants to share any video with the personas, I want to see what is happening there, I want to ask about that, or show an interaction on internet, they can see that in a certain way. Also, each moving piece could be improved independently, which is huge and is very useful. The AI models also, we can also have like a specific AI models in each module. Let's think, for example, in the MongoDB, we can have there a clustering model, and it works only there, and it makes it better, and it's not affecting any of the rest, and we can just improve that. It's also very useful. Then we have memory optimization, and it can make it custom. Maybe in the bot that I show you, it doesn't look so powerful, but let's think like instead of creating like custom bots for each of our clients, the RAG itself will learn and make it a custom for each of the users by itself, which is also very powerful. And again, we can decide if learns from it, like we can have like a learning workflow, a human in the loop workflow, or any other kind of evaluation in there. And at the end, for you, what I would like you to have, I need to delete this part, is like, okay, RAG is not adding a database. Calling a database is much more flexible than that. It's very powerful if you use it correctly. What I truly want you to focus is in the architecture. If you have the opportunity, you can move it the way you want it to. You can change it, adapt it, put agents wherever you needed it. And even create internal loops and internal workflow complex workflows for different use cases. There are also ways, for example, or having, for example, no embeddings in certain part of the RAGs, so we can have parametric, non-parametric combinations. We can overcome the limitations of the LLMs easily just adding a RAG in certain part of the process. And again, it's better to ask freshness, accuracy, reliability in all the process. And again, in the sites, it's like, on the challenges, it's like trying to decide what is the chunk size, what is the invariance model, what is the similarity measure that we're going to use, are we going to use any models there, what will be the best model, how can we improve the speed, accuracy, and the cost balances. And it also helps a lot with that. So creating a RAG is much more cheap than fine-tuning a model, for example, and it's also low maintenance than fine-tuning a model. And at the end, in the productivization, is like having monitoring, evaluation, and security is very easy to add it here, and it's very useful and easy to track. And all the time, it's very critical right now, every time that we deploy anything new. So something that is very useful is for the future, agentic, even in RAGs, is what is coming, is very flexible. It gives a lot of power and makes the systems more intelligent more easily. Yep. And questions that you may have.